So I'm going to talk to you about kind of like ending what we call a DAG distress. So we'll kind of talk into that. I have some analogy that I came up with. Hopefully it makes sense. We'll see. So again, my name is Hasson. I'm currently the head of product at a company called Upsolver. I'm also leading some of the community and developer advocacy efforts within our company, and you kind of see why we're building a data platform to really make it easy for anybody to be able to build data pipelines, get data into the organization so they can run queries and actually use it and use some of the awesome semantic AI stuff that we just saw. Previously, I worked for AWS, so I was a part of the initial team working on Amazon Athena based on the Presto engine early on, added recent support for Trino. I also worked with the EMR team, supported customers who were building platforms with Spark and Presto. I was a product manager on the AWS Glue and Lake Formation team. So lots of experience in this area. I've been talking to a lot of different customers for 6+ years on how to bring analytics into the organization in a much more organized way, so it's not chaotic, not everybody's going out and doing their own thing. How do we simplify it for the entire organization? So one of the things that always comes up is this idea of self-service delivery of data, right? We talk about having IT teams, there's data teams, there's platform teams, there's a million different teams that are able to bring data in a unified way to the business side of the house, so they can run queries against it, they can do analysis, but that process is really slow. So there's this starting kind of like exercise around how do we give our business users more autonomy? And we can talk about what does self-service actually mean, but in reality, what these users really want is a way to get data into their platforms, whether it's using Presto or whatever that may be, in a quick way. But to do that, it actually takes time. It takes effort. Not every person can stand up one day and say, I want to build a data pipeline today, and I want to bring this unique data, I want to transform it, and then I want to start querying it. So how do we do that in a simple way that's easy for people to just pick it up and go? So here's my analogy. So data pipelines, if you think about it today, majority of them are batch pipelines. And that's what we all been using, that's what we all been doing, because it's easy. If you make a mistake, you just rerun the job again and you fix it. So it's like taking a lot of different steps. And if you do one simple job, no big deal, you can run it, everything's cool. But most of the jobs, once they start using it, now you're adding another capability. You want one more thing and one more thing. Now you end up with 5, 10 jobs that you have to build some kind of orchestration around them. And this is where the problem starts to kind of duplicate itself or multiply itself. So we don't want to end up like this nice lady here, right? Building pipelines, and then you start realizing very quickly that you're spending a lot of your time actually dealing with how do I orchestrate this thing? Like I got a bunch of jobs, do I go use some bash script to do it? Do I write some Python code? Do I use AWS step functions? No. In the world today, everybody's saying, use Airflow. That's the best way to solve your orchestration problem. It's pretty popular, it's pretty cool, nice tool, but at the end of the day, you end up with something like this. Not everybody does. This is from a large company who has a lot of problems, but what I've seen with my customers is that even simple users that are trying to simply bring some data into their data lake to be able to run some queries against it, they need to figure out how to bring data from Salesforce, from MySQL database, from SQL Server, bring it together into the lake. Now they got to do some transformation. They got to clean it. The gentleman here talked about a bunch of column names. Sorry to pick on you. A bunch of column names that are super long and super complicated. Somebody needs to model this and make it easy for the user to actually understand. So you end up with these DAGs, these orchestration flows that slowly become more and more complicated, and eventually you're going to have to manage them. You're going to have to deal with them. If somebody else wants to reuse your table that you just created for yourself, well, now you got to make sure that that DAG actually runs every hour or every minute or whatever that may be to keep populating that data. And if it doesn't, well, that person who's using your table is going to come screaming at you. And you're going to say, that's not my job. I'm just an analyst. Don't ask me about why this DAG failed. Right? So what I've seen in my conversation with customers is that you kind of give a lot of these tools to the users, and you're telling them, hey, go do whatever you need to do, be self-service. But at the end of the day, this is a leaky abstraction. We should not be giving our users access to these heavy machinery when it's not really their job to do it, right? So at the end of the day, you're just creating more work for yourself. what we really want, not stairs, we really want elevators, right? But elevators in this analogy is really akin to stream processing. And that's kind of the nirvana. Ultimately, that's where we're going to be. Lots of talk about when, why, how. Let's just say it. It's going to be there. Maybe not today, maybe not tomorrow, but stream processing, stream ingestion, real-time analytics is going to come. But it's a little bit advanced right now. Most companies just can't fathom how do they move from batch world to the streaming world. And we can talk about some ideas how I have to do that, but regardless of that, it's a little bit harder. I'd rather have, I want my trusty stairs. Can you imagine the first person that had to ride the first ever elevator? How that felt, going from stairs, knowing what my legs are going to do, to go into some scary thing that just pulls me up and then maybe brings me down, I don't know. So it's a scary endeavor. The same thing with stream processing. So what we really want something like this. We really want an escalator. It's basically stairs that we know how to use, right? Batch processing, we understand it. Multiple jobs, stitch them together, job's done. Right? But we want the ease of use of being able to just stand there and let the thing just carry you, right? Let the thing just do the heavy lifting for you. Using something like Airflow is not the answer. That's basically giving you a bunch of ropes and saying climb up the stairs by yourself. So how do we do that? So in Upsolver, we built this product that we call SQL Lake. Behind the scenes is a batch plus streaming engine that allows the user to drive it using SQL. And it's really that simple. You write a little bit of code. I know it's a little bit hard to see, but at the top we create a connection. That connection may be to a Kinesis stream, Kafka stream, S3, MySQL, Postgres, whatever that may be. We create a bunch of connections. Then we create some staging tables. And these staging tables live in a data lake. Right? We automatically assume that we're going to build a data lake for you in Amazon S3 because it's cost effective for raw data. There's a lot of benefits in being able to replay the data later on, et cetera, et cetera. And then we create a simple job. And this is just a couple lines of code that simply says copy the data from the source, Kafka, Kinesis, whatever that may be, and land it in a data lake. The user doesn't actually need to know anything. They don't need to know how to partition the data, how to convert to the right format, how to compact the data, right? Merge small files into big files. Don't have to do any of those things. That's all handled for you by the system, right? That's the escalator. I have a bunch of steps that I need to take, but I'm just going to stand in one place, define what those steps are, and let the escalator take me, right? So all the auto-generating of orchestration, right? You saw that big DAG? That just happens behind the scenes. That's not your business. It's not your problem anymore. You don't need to worry about it. And then the second step of this process, once you stage and you land the data in the data lake, now you can actually give the true self-service access to your users to say, go write some SQL query to be able to transform, model, and analyze your data, and we'll just write it, we just run it as a job. And something that we do here is we actually model our SQL around Presto. So if you're familiar with Presto already and you know how to write Presto queries, you can take the same query, the same syntax, and you can stick it into this job framework and just run the job, right? And we just run the job behind the scenes. We let you, we basically do everything for you. You don't really have to do anything, and then everything runs. One thing that it's kind of hard to see here, but there's a sync command or the sync keyword and the job on the bottom. What we do actually is we synchronize the jobs together. So if you have a pipeline that stitches a bunch of jobs together, and they're all synchronized jobs, sync jobs, you can create non-sync, but the easy one is to do sync. We basically make sure that data flows across these jobs in a synchronized manner. So we actually synchronize on a timestamp, on an event time. So if there's event time coming in from Kafka or Kinesis, if not, we'll actually generate one when we ingest the first event. And then we stay synced across all those jobs on that timestamp. So if we're processing a certain event at a particular timestamp, we're never going to run ahead. We're never going to jump ahead. We're also not going to fall behind, right? We're going to stay in sync. If a job is processing and it's lagging, it's starting to fall behind, we'll basically pause the inbound traffic and we'll wait for the job to catch up. So we're always synchronized. There's a benefit to that because it allows that if, for example, a Kafka stream dies for whatever reason, no more events coming in, we pause that ingestion job. So any job upstream that's maybe doing a join against additional tables plus that stream or an aggregation of that stream do not continue running and potentially producing errors or null values because there's no more events to join or aggregate against. So this is something that typically in an Airflow model, you'd have to figure out on your own. Job one completed, Do I have data? Is the data good? Am I missing events? And only after that would you run the second job. So that's left for the end user to be able to figure out. That's not something analysts or business users want to ever do. So just to kind of try to summarize a little bit this analogy between batch, which I call stairs, streams, which I call elevators, and then what I call active pipelines are kind of like escalators. So in a batch, micro-batch world, very similar to the world we already know and love, you got Spark, Snowflake, dbt as that execution layer, Presto as well, but you need to wrap them in some orchestration. You need to do additional work to be able to get the job done. In the stream world, we don't have orchestration because it's just a stream, right? Data's always coming in. We know what to do with it once it arrives. If there's a problem, we can then replay the data. But the stream always continues to run. You don't have to schedule it or orchestrate anything. In this active pipeline world where I'm kind of saying like this is an escalator, this is a way for you to kind of bring both batch, micro-batch, and streaming together. But for the user, they don't really need to be aware that there's orchestration there because the orchestration is handled for you behind the scenes. And that's the big difference that I want to kind of have everybody take away from this short talk, is that you can make it easier for your users to actually build these data pipelines, both batch and streaming, right, without orchestration. You actually simplify the process completely for the user. So kind of what does that mean from an Upsolver perspective, the tool that we bring? The user writes a query, and they get a data pipeline. Behind the scenes, we do all the heavy lifting. The user runs that query. It just runs continuously behind the scenes and produces live data. It's declarative, obviously, using SQL. We infer all the dependencies, so you don't have to do anything there. It's fully integrated platform in one place. Whether it's streaming or batch or micro-batch, you don't have to run a Lambda architecture with multiple paths through the system. You don't have to orchestrate or schedule between them or synchronize them. Everything is managed for you in one place. And then the disruptive part of the pricing is that you pay when the data comes in. You don't pay when you do more with the data. So the more use cases you have to layer on top of that, you don't pay additional, right? Which is something that you see today with Snowflake or even Databricks or some of these other tools in the market. Because they're compute-based, you pay for the compute to bring it in. You pay for the compute every time you do something with the data. Whether you're just experimenting or you're building something for production, you keep paying over and over again. So that's pretty much it. I do have a quick demo if we have a couple minutes. Just kind of show you what I mean, and then, yeah, if you have any questions. This is kind of small. So one thing that we do is when you actually come into the Upsolver system, we expose a bunch of templates. And this is something that we try to make easy for our users to say like, hey, I want to get started today, but I don't really know what I'm doing. I just want to be able to bring data, let's say, from S3 and into Amazon Athena. Or I want to bring it from Kafka into Snowflake, or Kafka or Kinesis into Athena, right? I pick one of those templates, and then I just go with them, right? And we have the code in here. You can see it. I'll show you an example in a second. Pretty simple and straightforward. Now, just open up this one worksheet that I have. So we're trying to bring everything into one place for the user. So you can see in this example, I'm actually showing you a separation between the data producer and a data consumer. Something that we see often in new companies is that you have a team that just ingests the data, stages it in a lake, and then kind of walks away and say, okay, my job here is done. I'll make sure this is always consistent and working. Now, Mr. Analyst, business user, data scientist, come in and build your business logic transformation and produce a table that works for you. Don't bring me into the mix of that. So in this case, my data producer is creating a connection to S3, as you can see up here. And then they're creating this table. And this table is basically just a staging table. You can see I'm not defining a schema. So we do automatic schema inference and detection and schema evolution. We do have an event date system column. So if your data doesn't have a column that you can use for partitioning, we'll inject one so you don't have to reprocess the data from scratch. And then the job that you're running is this very simple one, right? It just says copy from the S3 connection that we define up top that has credentials, pick a bucket, pick a prefix, and then what target table you want to write into. And then it just runs behind the scenes. You don't really have to do anything. And then when I run this query here, this is actually executes on Amazon Athena behind the scenes. And this is just a simple query, not really sexy, there's really not much to it, just some data. But everything is handled for you here from within the product. So now a data consumer comes in. This is the self-service aspect of it. I already know that there are tables available. I can look on the side here on my catalog. I can see I got a bunch of raw tables that I can play with. I can click on a table. It can actually show me some statistics. I can see the health of that table, how many events are coming in over time. I can see the columns. I can see what values I have. I can see whether the schema was modified recently, right? So when was the first time I saw that column, and when was the last time I saw that column? This is important. If new columns are added or removed or modified, you can see that. So it's kind of all here in front of you. And then what the user does is simply create a table for themselves. Again, doing schema detection here. You can define a column list if you wanted to. And then this is it. This is the job that you run. So you create this job, but behind the scenes, you're just running this query. All this other stuff is just boilerplate. You can just copy it from the template. And then you just run this query, and then we execute that as a job, and then the job's running. That's it. You don't really have to do anything. And as you can see here, we're writing into this particular table called orders transform data. We can actually click into this order transform data, and we can see that we actually have 2 jobs on that table. This is actually important because now you can see that there's a table and there's actually jobs producing it and jobs reading from it. So you know that, hey, this table is being used by other people. There's a publish to consumer job in here. I can click on it and I can actually see what the code looks like. So if somebody else in my company came in and built a job on a table that I manage or a table that I've been using, I can see what they're doing as well. So there's a lot of transparency here from an organization perspective to make sure that people understand what's being done with your data. So yeah, that's pretty much it. And then the sharing aspect of it, be able to take data from your data lake and actually share with other AWS accounts is a pretty powerful use case that we're seeing more and more, where we have a data lake account, a team that's generating data. This may be a product team or a particular application team that has data to share. They write it into their own data lake, their own S3 bucket in their AWS account, and then they use Upsolver to be able to actually transform the data, model it, and then publish it to a different AWS account. So if the marketing team wants it or a different team wants it, they actually do that. So they create a connection to a different AWS Glue catalog, different AWS account, and they create a table in that account, just like we did before, and then they create a job that reads from the staging tables that they created in their own account and writes it to the table in the other account. There's no cross-account permissions here. There's no configuring, anything like that. We just do it all for you behind the scenes as long as you have an IAM role that has the permissions on the other catalog. So that's really very, very simple. We have more and more customers that are using this pattern to have kind of like a central data lake account that shares with other account or even application teams that are sharing into a central data lake account, and then from there, everybody else consumes that data. So that's kind of the short version of this. Lots more stuff to do, but yeah, hopefully this was helpful. If anybody has any questions or concerns or issues, love to hear it. If not, find me online. Check us out on upsolver.com. Thank you. Yeah, go for it.
So for the files that you write in your jobs, I guess they get written to S3, but in what format, like Parquet, the user specify?
Yeah, so good question. So today we basically write everything into Parquet. You do have the option as an advanced user to choose a different format, but by default we choose Parquet for most customers. Today we don't support formats like Iceberg and Hoodie. We do plan to support it in the near future. I knew where you're going. What we do today actually is that we write the data into S3 in Parquet, and then we actually build Presto views on top of that lets us do basically merge on read kind of work, and then we do compaction behind the scenes continuous. Like every minute we compact the data so you get fast access to the latest information.
Okay, so the metastore that you use is
it's Glue.
Glue
Data catalog, yeah.
Okay, and the file sizes, can the users dictate how big their Parquet files need to be or do you have like a set size of when you write it down? So
we default to 128 meg. We don't expose the configuration to users currently. We actually haven't gotten an ask for it to expose that. Customers are like, I don't really care, I don't know, you figure out what the best practice is and just do it. So that's what we've been doing. But we can expose it, we just don't do it today.
And compression by default.
Compression by default, yeah.
Okay,
Yeah.
thank you.
Yep, you got it. Thank you.
So you spoke of that you can see if other people are using your data, right? But what if you don't need that view anymore, that materialized view, that you just wish to delete it because it's costing you money to maintain it,
Yep.
right? And then you have 6 other people depending on it. So then how do you handle that?
So good question. I think that's a problem that exists everywhere. So within Upsolver, you can basically drop your job. So you're no longer populating data into that job. So it just historical data stays there. You can set retention. So if you have data past a certain amount of time, it just automatically deletes. And then the actual deletion of the table, like we don't delete it. So you can delete it from Upsolver. You can do a drop table, delete all data. We don't notify any users today. Today is just deletion off of the catalog. You can define on a catalog a policy that says do not allow deletion, and then we can't delete anything from a table. In the future, we're looking at adding notification within the Upsolver system to say that if you're going to delete something, then we won't let you delete if there's dependencies on that table. So if you have another job reading from that table, you can't delete it. Like you'll say, hey, this job depends on you. You got to stop that first before you delete. But assuming it's only your jobs and you delete everything, now you want to drop the table completely, we do allow you to do it in Upsolver. In the future, we're looking to add notifications. So you'll say like, hey, when you delete this, we're going to send a notification through CloudWatch notification so users can be aware of that. But I don't think there's a really good way today to notify all the potential consumers of it because we may not know who that is, right? Because you can have lots of people querying it from many, many different tools.
Even things like changing it from running once a day to once monthly.
Yeah.
It seems like other consumers would want to.
Agree. So we expose that information within Upsolver, so if consumers do come to Upsolver to see it, they can. Yeah. Yes, I agree. I've had conversation with some catalog companies to see how do we expose that metadata upstream to them. I don't think there's a really good answer to this because you do need some kind of unified place for all the users to come in to be able to be notified when things are changing, right? Otherwise, they have to jump from place to place.
And they can change the schema, right? They can drop a column or something like that.
Well, most users can't, right? Like if you own that job, then you can do that, right? Yeah.
And then that would screw up these other consumers.
Of course, but just like I can do that anywhere, right? So we're looking at putting some kind of data contract, you probably heard that a lot, to kind of say like, this is how we're defining this table, the rules, but there has to be some access controls around. Not every Joe Schmo can do something like that, but yeah.
So I just saw one slide showing the pipeline from source to target, but do you have a graphical representation for whole pipeline or just only from source to target?
So the example I showed you was actually one pipeline, but it was 2 parts. There was a from Kafka to S3 as the staging step, right? And then the other one read from the staging table, transformed and did some aggregation, and wrote back out into the data lake, into like an Athena table. So it's a 2-step pipeline. You can stitch more along the way, right? The way that we handled it is everything inside of Upsolver is treated as a table. So even though you read from a Kafka, the output of that Kafka stream is a table, right? So you can always read from that table, aggregate, and create a job that outputs out. So I just showed you a pipeline with 2 steps in it. Okay. You can do as many as you want, but in many cases, that's kind of most of it, yeah.
Thank you.
Yep. Awesome. No other questions? Cool. Thanks, everyone. Appreciate it.